So today's topic is parallel lines and transversals. So what is a parallel line is our first vocab word. Parallel lines are lines that are on the same plane, but they don't intersect. So for example, I have JK and LM. They are parallel lines. In notation, we use this symbol right here that looks like, two straight lines next to each other. That's my parallel symbol. And on a diagram, it's often going to get a little arrow like this to say that they're parallel. And if we have multiple pairs of parallel lines, you're going to see that we just keep getting more and more tick marks. Some other vocab words that go with this are skew lines. Skew lines are lines that are not parallel, but they also don't intersect. So this only happens if they are non-coplanar. So if you look at this diagram to the right here, I have those two lines, L and M. They are not parallel, but they also don't intersect one another. So we call that skew. And then last definition for this part is parallel planes. Just like parallel lines, parallel planes do not intersect each other. They're like floating above each other like this, right? So they don't touch each other. Any questions on those three? Now our big topic for this lesson, and really for the whole unit, is called a transversal. A transversal is a line that intersects two other coplanar lines. Excuse me. So that's our big vocab word here. Now if I look at this diagram, I see that I have two lines, line M and line N, and they are both being intersected by this line right here, which is called line T. Line T represents my transversal in this diagram. I can see that it is doing the cutting through of two different lines. And it forms kind of this like railroad track kind of design. Maybe it's a sideways H. There's a lot of different ways that we can look at it. Okay, so it's just a line that intersects two other lines. That's our transversal. At those intersections, here and here, we get a bunch of different angles. Okay, so there's 4 angles at the top intersection, 4 angles at the bottom intersection. Now, these angles have relationships to one another, and when we have lines that are parallel, so say that M and N were parallel to each other, they get special properties. That's what we're going to focus on today, is those special properties when those two lines are parallel to one another. So let's take a look at our first set of relationships. You're going to notice that in the words column, it is always being specific that I have to have two lines that are parallel. None of what I'm about to tell you is going to be true if my lines are not first parallel to one another. Now, in terms of symbols, this is what you are going to see eventually. Don't get scared. This is eventually what you are going to be seeing used in our proofs, is this like symbolic notation. You will get used to it very quickly, I promise. So let's look at our first relationship. The first relationship talks about corresponding angles. Corresponding angles, if my two lines are parallel, are congruent. So let's draw a little diagram here. I'm going to draw two lines that are parallel to one another. I'm going to indicate they're parallel with a little tick mark. And then I'm going to draw a transversal through that. Now, angles that are corresponding lie in the same position on the intersection. So I want us to kind of think about it in terms of like a compass, not really, but like kind of a compass. So I see those two intersections, right? The northwest section of this top intersection and the northwest section of this intersection are corresponding. So this angle corresponds to this angle. And we can keep going here, right? So this angle corresponds to that angle, the northeast corner. In the bottom here, the southeast and the southeast, and the southwest and the southwest. We got to get a little creative with our tick marks here, but those are corresponding angles. And because those two lines that I drew are parallel, I can say that each pair of corresponding angles is congruent to one another. Any questions on that? Okay. Then we're going to get a little bit fancy. We're going to go to the next kind of relationship. The next kind of relationship is called alternate interior angles. So again, let's draw my little diagram. I'm going to make these two lines be parallel so that all my fun properties can be true. And I'm going to break apart this relationship. The first part it says is alternate. Alternate refers to alternate sides of the transversal. So here's my transversal. I'm going to highlight it in blue. Alternate angles means that one would be on the left side of this transversal and one would be on the right side of this transversal. The other part is this interior part. And interior refers to the interior of the parallel lines. So if I think about this as like railroad tracks, the interior angles are all the stuff in between those two tracks. So an example of alternate and interior angles would be this pair of angles here, one on each side of the transversal, but still on the interior. Or it could refer to maybe this pair of angles right here. And again, we are saying based on that relationship, if those lines are parallel, those pairs are congruent. Questions on that one? The last relationship that gives me congruent angles, very similar, is alternate exterior angles. So again, alternate meaning on opposite sides of this transversal, but this exterior now means that I'm going to see my angles on the exterior of those parallel lines. So once again, one on each side of that transversal, but now on the outside. Same thing over here. One on each side of that transversal, but now on the outside. And again, those are telling me that they're congruent. Questions on these three so far? All these three relationships give me congruent pairs of angles if those lines are parallel, which I did not draw on this one. Bad. There we go. Okay? Then the next kind that we have, kind of similar in the same vein here, SS stands for same side or consecutive interior angles. I like that word consecutive better. Same side meaning of the transversal. So let's draw out my little diagram again. Two parallel lines cut by a transversal. And if my angles are on the same side of my transversal, it means they're either both going to be on the left or they're both going to be on the right. Same side interior, I'm expecting those two angles to be on the inside of my railroad tracks. So that's going to look like in this diagram, this angle here and this angle here. Notice, I am not saying that these two angles are congruent. I'm saying that these two angles are going to add up to equal 180 degrees. I can do the same thing on the other side. I'm not going to say that these two angles are congruent, but I am going to say that they add together to equal 180 degrees. And then lastly, let's finish it off. I have same side exterior angles, and they have the same property, same side exterior angles on the same side of my transversal, also equal to 180. So this guy and this guy equal 180, and these two here equal 180. That's a lot. Any questions on that? All right, moving on. Let's look at some naming. Remember, notation also doesn't go away, so we want to make sure that we have good notation. In letter A, it says name all segments that are parallel to BC. I like to highlight what I'm looking at, so here's BC right here. Can somebody give me one example of a segment that is parallel to that segment? Yeah. Perfect. FG is parallel. I could say AD is parallel, and I could say that EH is parallel. And I think those are all the ones that are parallel to BC there. Now, in the same vein, name a segment that is skew to EH. Here is EH. By definition, that word skew means it is not intersecting and it's not parallel. So all of those things that I just said were parallel to BC cannot be skew to EH. What's a segment that is skew to EH? There's a lot of examples on here. Give me one that is not parallel and also doesn't intersect it. Yeah? Perfect. That is a great example. CF. Notice they are not parallel, but they also are never going to intersect. I could use DC, I could use AB, BG. None of those are parallel and none of them intersect. Good? Okay. A plane that is parallel to plane ABG. Here's plane ABG on the bottom. There's only one correct answer here. What plane is parallel to that bottom plane? Yeah, Anna. Perfect. This plane on the top. Remember when we name planes, we use that word plane and we give it 3 letters, 3 capital letters. So DCF works for me. Questions here. That naming stuff also doesn't go away. So don't be nervous about naming things. All right, are we ready to talk angles? Let's look at these angles examples. So in number 2, very common diagram that I see, it's a triangle and it's got some pieces labeled. The number one thing that I recommend you do when you tackle one of these diagrams is kind of expand it, because it's much easier to look at something when it's like clearly this H shape as opposed to this triangle, which maybe looks a little bit confusing. So I'm going to expand and extend my 2 parallel lines. I know that these are my parallel lines because of these nice tick marks that they gave me. And I'm going to extend my transversal, which is this line right here. Now I see the H shape, right? That's the thing that I'm looking for. I'm going to highlight where my 2 angles are. It's referring to that angle right there and that angle right there. Now look back at your last page. What's the relationship between those 2 angles? There's 5 relationships that I just told you about. I know they're fresh. What's the relationship between those? Yeah. Perfect. They are both in the west position, I would say, of this intersection. They're in the same location on the intersection. So they are corresponding angles. And because we know that these lines are parallel, we also know a property about these angles. What do we know about those angles? Yeah. Exactly, they're congruent. So I can set them up in an equation that sets them equal to one another. I'm actually going to write out this whole thing. Parallel lines imply that corresponding angles are congruent, 3x minus 10. And I'm going to solve. 50 equals 2x, or 25 equals x. Perfect. Any questions on that piece? Okay, let's look at number 3. I promise I won't make you do all of these, but we definitely need to do some of them. Number 3, I'm going to highlight. I have 2 lines. I have a transversal, and I have some angles. What's the relationship between these 2 angles? Casper? They're interior. What else? Dahlia? What are they called, though? What's the name that I'm looking for? There's something interior angles. Yeah, Ian? Same side interior angles. So yes, same side, or I prefer the term consecutive. And then Dahlia says that they equal 180. I would agree with you 95% of the time. Why can't I say that these 2 angles are supplementary based on just this diagram alone right now? I did this to trick you. Caitlin? Yeah, technically there's nothing on these 2 lines right now that's telling me that A and B are parallel. There's nothing in the directions, there's nothing on the lines, so I can't just assume that lines are parallel. However, if I go and tell you, okay, A and B are parallel, so then we know that they are supplementary, what is the equation that I would set up to find this? now that I know that they're parallel and supplementary? Any ideas? How do I set these up in an equation? Oh no. Yeah. Perfect. We add them together. We set them equal to 180. So this is 7x plus 54 equals 180. Or 7x equals 126. I don't know what this gets me. 18? Does that sound right? Oh, goodness. All right. Any questions on that one? Let's look at number 4 because number 4 gets a little bit tricky. Notice, I have lines M and N, which are parallel to each other, and I have lines P and Q, which are parallel to each other. This is super common where we have a diagram that has more than one pair of parallel lines in it. What I recommend you do is I look at the angles in the question. So angle 5 and angle 7, I'm going to highlight them. Here's angle 5, here's angle 7. Now, based on my properties, based on all that, they have to lie on the same transversal. What is the line that they have in common, angles 5 and angle 7? Caitlin. They are corresponding. What is their transversal? What's the line that goes through both of them? Anna. M. Perfect. Which means that the two parallel lines are going to be P and Q. And like Caitlin said, these two are corresponding angles. We know that corresponding angles are what? If those two lines are parallel, we know that those two angles are perfect. So I can set them equal. Now you're probably thinking, okay, why did we have to do all of that highlighting and stuff? Because it gets a little bit tricky, right? We want to make sure that we are looking at the correct part of our diagram. When I'm going through problems with you one-on-one, I will most likely use my hand and cover up this whole half of the diagram so that we can't see it so it doesn't confuse us. Because when we have more than one angle going on at the same time, things get tricky. So cover it up, put highlighter on there, whatever you have to do to make sure that we're looking at the correct two angles. So let's erase all my markings here. Let's start over. I have angles 4 and 8. What is my transversal? What line do they share in common here? Casper. Perfect. Which means that these two lines right here are my parallel lines once again. What's the relationship between 4 and 8? Go ahead. If you got it. Yeah, if you got it. Perfect. They are on the same side of that transversal, and they are exterior to my two parallel lines. So what's their relationship? What do we know about them? They're either congruent or supplementary. Which one is it? Catherine. Perfect. So let's add them together. 4 times y minus 25 plus 4y equals 180. This is 4y minus 100 plus 4y equals 180. 8y equals 280, or y equals, I believe this is 35. Oops. Any questions on this? Are we okay if I do a little bit of skipping around? You'll get good practice on this. What I want to look at is number 7. Number 7's a weird one. Okay. What do I notice about this diagram here? I have my two parallel lines. Is this a transversal? No, it's like a bendy line, right? I could make two separate transversals if I extended that line, but I don't really have one solid transversal. I could make a transversal there. I could make a transversal there. So a lot of the times, actually not a lot of the times, let me not lie. Sometimes when I look at a diagram, it's not always drawn out everything that I need to solve the problem. Sometimes we have to get creative and construct our own lines to help us solve this problem. Because right now, how the heck am I going to figure out what x is? So what I'm going to do is I'm going to draw in a third parallel line in a location that's going to help me break this problem down. If I have two separate transversals, okay, and they're intersecting right here, I want to draw a parallel line through that point so that I can get some nice angles that intersect here. So let's draw. I'm constructing a line. I'm making it so that it is parallel to these other two lines. And now, hopefully, we can kind of see what's going on here. I'm going to look at the top of my diagram first and compare this transversal and these two parallel lines. What can I fill in here just looking at the top? Actually, I can probably fill in a lot, but what's going to help me find that X? What do I know about this angle right here that I just created? Kaylin? Yeah, what's the relationship between those two? Perfect. These two angles are corresponding. So I know that they must be congruent. Amazing. Let me get rid of some of my highlighting here. Maybe. Now let's focus on the bottom part of that angle. Let's look at a different transversal. Now what do I know about this part of my angle? Uh-oh. What's the relationship between that 100 and that angle that I have highlighted? Yeah, they add up to 180. They are same side interior angles. So they equal 180, which means that this little sliver over here is 180 minus 100, which is 80. Which means, what's the measure of this whole angle X that I was trying to find? Not a trick question, yeah. Yeah, we add them together. 50 plus 80 means that that little angle in there must be 130. Any questions on that? So don't be scared to construct your own little lines in there to help you. That's a very common problem. You're pretty much going to do this every single time. Draw a line through that little corner part. All right, are we good? Any questions?